Hello, algebra people. Last lesson, we talked about how to graph functions, even functions you didn't really know what they were going to look like. And this time around, we're going to work on the other side. We're going to work on actually finding function rules and writing the math sentences, let's say, for each situation. And I thought probably maybe the best way to go through this is just to do a whole bunch of problems that like what you might see in your homework, and maybe those situations will help make sense of the ones out of your book. This is one of those things where like the more of them that you do, the better you get. And so rather than just look at like one example from each type of problem, I thought, well, let's work a bunch of them and see what happens. So we'll try to get through this rather quickly, but keep in mind, I'm going to point out some key things that you can look at to help you with doing this. And the first one I want to point out is the word is. The word is means equals, right? So in English we say is, but in math we really think equals. So here it says 5 less than 1/4 of x is y. So we know that there's going to be an equal sign where the is. But the other term that I want you to focus on for right now is less than. And I know that in math we have a symbol that is the less than symbol. However, that's not what we're talking about in this case. What we're talking about here is really the idea that some number is 5 less than where we started, okay? And if I'm going to be 5 less than where we started, that means I'm going to be subtracting 5, okay? So when you see a term like less than used in this case, it means we're going to be subtracting this number. How do we write then the term 1/4 of x? Well, the other thing that you should be aware of is the word of usually means multiply. So of means we're going to multiply. 5 excuse me, 5 less than 1/4 of x is y. So we're going to start off with 1/4 of x. So I'm going to write 1/4 times x, because of means multiply 1/4 of x. And then it says 5 less than that. So I'm going to do 1/4 of x and minus 5. So that part right there is 5 less than 1/4 of x. This is 5 less than 1/4 of x. Is y. Again, is means equals. Next one. 7 more than the quotient of a number n and 4 is 9. So here's the keyword is again. I know that's going to be an equal sign. So somewhere in here, I'm going to say equals 9, right? But just like the first one said 5 less than, and that meant we're going to subtract 5. This one says 7 more than. What do you think that's going to mean? Yeah, it's going to mean we're going to add 7 to whatever. And then quotient. And hopefully we remember that quotient means to divide, but that's going to, for us, that's going to mean that we're going to build a fraction, some number over another, okay? So this means a fraction of some type, right? We're going to say one number over another because the fraction bar is a division symbol. So here we go, 7 more than the quotient of a number n and 4. So when I say quotient, I mean I'm going to have a fraction bar. So quotient of a number n and 4, when it says quotient, the first thing that it gives you goes on the top of that fraction bar. So I'm going to say n, and the second thing that it gives you, and 4, goes on the bottom. the quotient of a number n and 4. This is how we write the quotient of a number n and 4. But we're supposed to do 7 more than that. So I'm going to say plus 7, and that is equals 9. So this is 7 more than the quotient of n and 4 is 9. Let's try the next one. P is 9 more than half of Q. 9 more than is like 7 more than. That means at some point we're going to add 9. Okay? And here we have P is. So I'm just going to write that down. I'm going to go P is, because remember, is equals. P is 9 more than half of Q. And remember, of means we're going to multiply. What's half? Well, that's 1/2. That's half. Half, right, of Q means I'm going to multiply 1/2 times Q. So 1/2 Q, right? 9 more than that, plus 9. P is 9 more than half of Q. Next one, 8 more than 5 times a number is negative 27. Well, what are we going to do with 8 more than 5 times, right? Well, that means I'm going to add 8 at some point. Let's look at the other piece, though. It says 5 times a number. How do I represent 5 times a number? Hopefully, 5 times a number, we can say like 5x. That's not a multiplication symbol. That's the variable x. 5x, right? Plus 8. 8 more than 5 times a number. This is 8 more than 5 times that number. Is negative 27. Next one, 1.5 more than the quotient of a and b is, or a and 4 rather, is b. 1.5 more than means I'm going to add 1.5 to something, right? What am I adding it to? Well, the quotient of a and 4. And like we said before, quotient means we're going to have a fraction bar. So we'll build our fraction. What goes on top? The first thing that it lists after quotient, quotient of a goes on top. What goes on the bottom? Well, the next thing it says, 4. Quotient of a and 4. So 4 goes on the bottom. And we want 1.5 more than that. So a over 4 plus 1.5 is b. There we go. All right, let's move on to the next section. This section is going to be heavily dependent upon something that I like to call y equals mx plus b. That is our slope-intercept form for a linear equation. And we know that m is our slope and b is our y-intercept. But I am going to say, for these, your slope is a rate of change. So when we're talking about m, we're really talking about our rate of change. That m value is our rate of change. And b, which we all know is the y-intercept, in this case, we're going to call it the initial value. Initial means where we start from. So that's our initial value. So like if someone was going to charge us money for a particular task, they might say, hey, I'll do it for, this much plus another per unit that they're helping us with. If they start off with this much, just to start with, like for example, if I wanted someone to come and work on my plumbing, that plumber might say, well, I charge $100 for the call, and then so much an hour after that. That means that he's going to charge me an initial fee just to come out to my house, and then he's going to charge me so much per hour after that. So initial value is what he's going to charge right up front, and then he's going to charge me like some rate of change, so much per hour after that. Let's see how this works. This is just a template. I'm not always going to use y. I'm not always going to use x, but I want you to think of m and b as rates of change. M is your rate of change, and B is your initial value. So we're going to create functions based on that template. Here, this one says the price P of ice cream is $3.95 plus 85 cents for each topping T on the ice cream. There are some key words I want you to look for, one of which, or two of which, I guess, for each is two words. I can count. Yeah, I can count. But the term for each is a term that always indicates the rate of change because they're going to charge us $85 for each topping, right? That means that the price that I'm paying is changing each time I add a topping, right? And there is an initial fee. They're going to charge me $3.95 for ice cream, right? So initial value is $3.95, and then our rate of change is 85 cents. Let's build this using their variables. It says the price P. So P is what I'm going to write down instead of Y. P is equal, or price is equal to, I'm going to write blank plus blank. Okay, there's two blanks here because I got to find my M and I've got to find my B. M is my rate of change, and since it's 85 cents for each topping, this indicates that 85 cents is my rate of change. So I'm going to write 0.85, and it tells me T is the other variable that I'm going to use. So I'm going to use T instead of X and say it's 85 cents per topping, right? 0.85 T plus my initial value, which was $3.95. So here we go. We're going to use the same template for each of these. Next problem. A babysitter's earnings, E, are a function of the number of hours worked, N, worked at a rate of $7.25 per hour. I'm going to write E instead of my Y. The earnings is going to be equal to blank plus blank. We're going to use this template, this Y equals MX plus B template. It's like Y equals blank X plus blank. Y equals blank X plus blank. Okay, we're not always using Y and X, but we are going to use it like a template. Y equals blank X plus blank, right? Okay, so the babysitter's earnings, E, are a function of the number of hours N worked at a rate of $7.25 per hour. Now, per is another keyword, just like for each were keywords. When you see per and or for each, that is always going to tell you that's our rate of change or slope. So right off the bat, if they're going to change per hour, I know it's 7.25, 7.25. That's my M, right? Per hour, and it says here that the number of hours worked, N, right, is my other variable. So I'm going to say 7.25 N. Now, do you see another value in there? Because if I look back to this problem, I said we're going to fill in these blanks with the numbers that they give us. We just have to figure out which one goes where. But here there were actually two, an initial value and then a rate for each topping. Here, is there an initial value? And the answer is no, they didn't give us one. It's not there. So if it's not there, we can just write 0. Okay, I can write a 0 there. So our initial value is 0. There's no initial value. But we are going to be charged a rate of $7.25 per number of hours worked. So, moving on. The price P of a club's membership, well, I think that's going to mean that we're going to go P is equal to, and I'm going to write my blanks in here, blank plus blank. $30 for enrollment fee and $12 per week. Do you see a key word that we've already talked about? And hopefully you do. Per. Before I said per is that indication that that's going to be a rate of change. It's $60, or sorry, it's $12 per week, right? It's $12 per week. So 12 is our rate of change. W is the other variable we're looking for here. And the initial value, what you have to pay up front, is $30. Before anything happens, you got to pay $30 to enroll. Then you pay $12 per week. So 30 is our initial value. Right on, right on. Okay, and remember, it's always this y is equal to mx plus b, our rate of change times the variable plus an initial value. It's real formula like thing. You just keep plugging away with the same formula. Plumber's fees F, so the F is our thing. Our fees are going to be $75 for a house call and $60 per hour. Do you see a keyword there? Blank plus blank. We're going to fill in our blanks with our M and our B, our rate and our initial value. It's $75 just to come to the house. It's $60 per hour. So hopefully you recognize 60 with that little per to help us out. It's $60 per hour. H is our variable plus our initial fee of $75. 10's a little bit different. A hot dog costs $1 more than 1/2 the cost of a hamburger H, but 10 store to start's going back and looking like some of these because it's using the same words. It's like more than 1/2 the cost of a hamburger, right? What did we do with the more than that was up there? Yeah, it was like an additional thing. We're going to add. If it says more than, we're going to add to that, right? So a hot dog, D, they're telling us our variable. D is equal to, right? 1/2 the cost of a hamburger, $1 more than that. How do I write 1/2 the cost of hamburger H? The keyword of, as we said before, means we're going to multiply. So down here, 1/2 is being multiplied times the variable H. 1/2 H, but it's $1 more than that. So I say plus 1. It still fits y equals mx plus b, right? It's still a linear function, but I might have to use some of the skills we had before, okay? Now these next two get a little bit more complex, but let's just read our way through these. Jose is 3 years younger than 3 times his brother's age. Write a rule that represents Jose's age, J, as a function of his brother's age, B. All right, well, we can do that. Jose, J, is, now I have to think about this because it's again, using kind of the same language. If somebody is 3 years younger than 3 times his brother's age, right? Think about how you could do 3 years younger. Like, if I'm 10 years old and you're 3 years younger, how old are you? And hopefully you say 7. And the reason that happens is because you're subtracting 3 because you're 3 years younger. So we know, or we should know, that we're going to be subtracting 3 years, right? But how could we write 3 times his brother's age? Well, if his brother's age is B, and you're going to do 3 times that, you're going to have 3b. And remember, we're going to be 3 years younger than that, so we're going to subtract 3. So Jose's age is 3 times his brother, but then you subtract 3, right? Now, that's our rule. How old is Jose if his brother is 5? Well, all we have to do is plug in 5 for his brother's age. So Jose would be equal to 3 times 5 minus 3. And 3 times 5 is 15. You subtract 3 from that and you get 12. So we know that 12 is how old Jose is if his brother's 5, for goodness sakes. Number 12 is a little bit tricky as well. Let me step you through this one. First of all, remember we're trying to get something that looks like y is equal to mx plus b. And by the way, all these up here look like y equals mx plus b too. But anyways, let's think about how this works. A taxi cab charges $4.25 for the first mile and $1.50 for each additional mile. Hopefully the words for each that we said were key are giving you a hint that one of these numbers is your rate of change, or M. And so a rule for describing the total rate, our rate is equal to, and I'm going to say blank plus blank, right? one of these numbers represents a rate. The other one is apparently an initial fee. So if we were thinking about y equals mx plus b, we would say 1.5, you could say 1.50 times m, that's our other variable, right? Plus our initial fee, which is 425. Now, this is what this is what we were doing before. We were just kind of going through what's our initial rate, what's our rate of change. However, think about the situation for just a moment. This initial value was supposed to be for the first mile. So if I just put the number of miles that we're driving or getting driven in for here, I must be paying an additional $1.50 than what I should be paying. So at some point, I got to get rid of that. I got to subtract it. And so there's two ways to do that. One, which looks a little more complex, would be say R is equal to 1.5, not times M, but times M minus 1, plus our initial rate of 425, right? Or we could say, you know what, I've got to subtract 1.5 off from here. So, if I took 4.25, hold on, I could subtract it off of there, but I'm going to leave it this way. What I'm saying is I could go ahead and pay $1.50 per mile, but then subtract $1.50 off of this because the initial mile should already have been part of that. I guess I'll write another one there. If I did 425 minus 1.5, then really I'm paying $2.75. So an equivalent expression would be R is equal to 1.5 M plus $2.75. So that would, either one of these would give you the same values. You can plug 12 in for your M and see that you'll get the same thing for both. But let's move on, though. Real quick, I just wanted to say, if you run into some problems where it's asking about the area of rectangles, hopefully you know the area for a rectangle is equal to the length times the width, okay? So if it's asking about rectangular area, it's length times width. But I did want to get through and talk about this one, which is talking about the area for a triangle. And the area for a triangle is 1/2 its base times its height. And let's see if we can actually come up with an equation for this, because there's a little bit of substitution that's going on as well. So write a function rule for the area of a triangle with a base that is 2 meters less than 4 times its height. And so if we're measuring everything in meters, let's write what this means. It says the base, right, is 2 less than 4 times its height. So the base is 4 times its height, but minus 2, right? The base is 2 less than 4 times its height. And again, that the key term less than 4 times the height is kind of like what we were doing here. 5 less than 1/4 of x is y. We can say b is equal to 4h minus 2 because it's 2 less than 4 times its height. But we had this equation over here. It said a is equal to 1/2 the base times the height. And so we could rewrite this and say that the area is equal to 1/2 of b times h. But b is this, isn't it? So instead of writing b, I could write 4h minus 2. So instead of writing b, I've written this, but I still have to multiply times h there, right? So this really says the area is equal to 1/2 of b times h, just like I wrote here, but I've replaced or substituted in 4h minus 2 for b. Why? Well, because b is this, and so I can replace anywhere I see a b, I can replace it with 4h minus 2. That allows me, that allows me to solve the problem, because it tells me what the height is, even though I don't know what the base is directly. So I can plug all that in. I can say, all right, let's do this. I'm going to put 8 in wherever C and H. So I'm going to say A is equal to 1/2 of 4 times 8, right, minus 2 times 8. All right. Now, remember, order of operation says you got to do what's in parentheses first, but once you're inside there, you still got to follow order of operation. You can do 4 times 8 and subtract 2. So 4 times 8 is 32, minus 2 is 30. And so then I'd have to take 30 times 8 times 1/2, which is going to be 120, I believe. You can do that in your calculator, but I believe you get 120. All right. So that was just me trying to go through and give you a whole bunch of examples of how you might set things up. If you see some common terms in here, maybe they'll help you do your homework as you go along. Again, the more you do these, the better you get at them. I know in the past you see words and you go, I'm not doing those ones, I'll just ask questions. But really, you should tackle these. They're not that bad. And like I said, the more you do it, the better you get at it. So take your time and get some of these done. Good luck to you. Hopefully you have a good day, and we'll be talking at you real soon. Bye-bye.